Good afternoon. Thank you for joining us for today's installment of the PENC webinar series. My name is Katie Cox. I'm the PENC Membership Director. I will be serving as moderator for today's presentation. Please feel free to use the chat box if you have any technical difficulties, and I will try to assist you. We will be taking questions at the end of the presentation today, and you can type those into the questions box, and I will read them out loud to the presenters. Today's presenters are Joseph Hummer and Ron Baynow. Joseph Hummer, PhD, PE, is the State Traffic Management Engineer with the North Carolina DOT Mobility and Safety Division and has been with the NCDOT for 4 years. He spent 27 years as a faculty member in civil engineering at 3 universities. Joe is the author of Driverless America: What Will Happen When Most of Us Choose Automated Vehicles, which was recently published by the SAE. Ron Baynow, PE, is an international transport research advisor with over 40 years experience in transportation research, development, and deployment, working with US DOT, the Florida DOT, and DeLue Cathar Engineers. He is active in technical committees in ITE, ASCE, ITS America, SAE, and TRB, and speaks at domestic and international transportation conferences. And today's presentation is Challenges to PEs from the Upcoming Wave of Automated Vehicles. Thank you, Joe and Ron.
Okay, thank you very much. You know, we began this, we titled this as Challenges to PEs from the Upcoming Wave of Automated Vehicles. These are interesting times, as I've heard one person explain. And another phrase given to these times are challenging times, and that's kind of what we're picking up on. But I've also heard other situations describing this current times as disastrous times. Well, I did hear one comment made from somebody who was referring to this as he said he never lets a good crisis go to waste. In other words, making advantage of the things that we have, the situations that we have before us. What we're looking at here is the development of automated vehicles. It's not only here in the United States, but it's global. There's a lot of cooperation, coordination, and collaboration that the US has been doing with other countries. But we're going to focus in on what's going on here in the United States. It's going to be our focus of attention for this particular session here. We'll go ahead and begin with a disclaimer first. I do want to point out that the presentation is the personal opinion of us, of the presenters, not the North Carolina Department of Transportation policy nor North Carolina law. We do have some graphics in here. The graphics are the property of the owners here, us presenters. And we do request that you do not reproduce any graphics unless indicated that they belong to the presenters, us, or the North Carolina Department of Transportation. And we do cite some specific products and services, but we do want to point out that there is no endorsement of any product is being intended by our discussion. For the objectives, the purpose that we're presenting here, we do want to point out that the automated vehicles will bring a lot of rather tremendous challenges and opportunities. We've cited both the challenges aspect and the opportunities aspects, and hopefully we'll be able to get this through to you, and we look forward to some of the questions and comments that you might have at the end of our presentation. So what we will do in this presentation is to go ahead and list the technical areas that are expected to be impacted, and you'll find quite a few of them that we list down here. Some are direct impacts, some are more indirect impacts, but we'll discuss several of these. We'll also provide a deeper discussion of some of the impacts in a few specific areas, just to help stimulate your thinking, because what we'd like to do is to challenge the professional engineers to take the lead, because there's going to be many opportunities. And a person doesn't really need to be a transportation engineer in this case, but rather there's a number of opportunities that we'll be discussing where you can jump in and really take the lead for this, because it's the engineering community that has a good advantage to be able to step in with their technical expertise and leadership that can be demonstrated. First, a couple of definitions or clarifications. What we're looking at is self-driving on-road motor vehicles. Level 5 we refer to, and these are SAE, Society of Automotive Engineers definitions. What we want to do is to point out that this level 5, level 4, both of these are going to be instrumental. I do want to point out, though, that there is a definition that has been given by the Society of Automotive Engineers on these different levels. There are 6 different levels, even though level 5 is the top one. That's because it starts off with level 0. There's no automation at all with respect, rather the driver does everything. But of these 5 levels, the distinction here for the higher levels is that someone will tell the vehicle the destination, the vehicle gets there, and then the driver turns on the engine, turns off the engine. That can also be automated in the top level. We do not need spatial infrastructure, at least not at this time anyway, but in the future, what we're going to be looking at is various modifications that is made to the existing infrastructure. And that, of course, has an impact upon other interests as well, cost-related things. We're looking at things that could be connected, vehicle communication connections, or not necessarily. And of course, the vehicle can run empty or only carry cargo. I want to be sure that we are talking about not only passenger movement for automated vehicles, but also cargo, freight-related issues. And that has an impact upon those that deal only in freight-related issues. What we're looking at here is impacts. The changing of people as they make choices on their mode of travel. There's various things. What we're looking at here is the automation that comes out from vehicles, the various levels of automation. And when I say the various levels, just briefly, out of the 6 different levels, I did make reference to level 0, where there's the driver really does everything. Level 1, where sometimes the driver will need to assist, or at least the driver has a primary role. Level 2, the human begins to interact with the vehicle. Levels 3, 4, and 5 are really considered where the vehicle takes over the operation of it. Level 3, there is a monitoring of the driver and driving environment, and the human driver must be ready to take back. Level 4, the automated system can operate in certain environments. And level 5, the top level, is where the automated system can perform all the different driving tasks. So this is what ASE, and not only here in the United States, but globally, that transportation professionals have tended to accept these definitions. Subscription service, one of the things that we found in the past couple of years is that there's a lot of shared ride activities. There are various subscription services. But another thing that we do want to point out in this presentation is that there's a move also towards electric vehicles as well. This especially comes out from some of the commercial or some of the consumers that are very interested in moving towards electric related vehicles.
Hey, Ron, this is Joe. Can I jump in there and just point out that, we really believe that all 3 of these impacts are interrelated with each other. Automated, subscription, and electric will more or less happen simultaneously and in an interconnected way. That, it's possible to imagine a gasoline-powered automated vehicle, but that's pretty unlikely, and there probably won't be too many of those driving around out there. So it's tough to untangle the effects of automated subscription electric, since they'll really probably arrive and be treated as a package deal. Thanks, Ron.
Sure, that's a good point. Before we move on to this slide too, it's kind of interesting, but of course consumers, those that purchase vehicles, have had a say and interest, but it seems like even more so in the past couple of years that there's a great deal of consumer influence over the vehicles itself. one of the companies, Deloitte, has looked at what's happening in the past decade in terms of personal preferences on purchasing a car. And I'll just make a couple of comments about that. But back in 2010, generally the overall value when evaluating brands as to what to purchase was kind of the key issue that most consumers are identified with, according to this one survey. Just a year later, in 2011, what most people were looking at is the actual technology within the passenger vehicle itself, what is referred to as cockpit technology. That was kind of the final point of decision for a shopping experience. A year later, hybrids were really much coming to the forefront, especially for cost and convenience and connectivity, information transfer from other places. But once again, safety was kind of the key issue that most consumers were looking at. 2014, there was a shared mobility that really started popular, became very popular. And in 2017, full autonomy was kind of a key issue that most consumers, when they were purchasing cars, were very interested in. But of course, with safety as a strong feature, because many people are still not sure of automation and its impact upon safety. 2018, what Lloyd has pointed out was that internal combustion engines were becoming less and less of interest. And finally, this last session in 2019, autonomous vehicles was kind of a key issue that most people were very interested in, but still with a safety-related issue. So that's kind of how the consumers were beginning to address the issues and how the vehicle manufacturers were beginning to adapt to that. Just a trend here with respect to the rapid, what would be considered to be the rapid rate of adoption. And of course, it depends upon, once again, the consumer interest areas, the ability for technology to develop a safe operation for automation. And this kind of shows what's going on here in terms of the overall trends. We will point out later in the presentation the significance that all the different professional societies, groups, organizations have in addressing the automated vehicle, especially the role that the U.S. government is playing in here. We'll discuss that in a later slide. Well, for now, we'll go ahead and turn this over to Joe for a continuation of our discussion on automated vehicles.
Thanks, Ron. Just on the last slide there, I wanted to point out that the adoption forecast, that was made by a gentleman named Todd Littman in Victoria, British Columbia, Canada, who is mostly a transit advocate. So I would view this forecast as a pessimistic one in the sense that he probably has an interest in not wanting to see automated vehicles adopted. So if even Todd Littman is forecasting, roughly 50% automated vehicles by travel in the year 2045 in a wealthy area like the Triangle or Charlotte in North Carolina, in a suburban area, we're likely to see well more than 50% if this forecast holds water. So yeah, good. Thanks, Ron. On to the next slide. I kind of feel like I'm one of those old white guys standing in that photo in this slide at the start of the interstate era. We looking at automated vehicles are standing on a similar precipice. We're looking ahead, and if you're thinking at all like I am, you're thinking we're about to step off the cliff here. This is going to change our world in so many ways. Look back in history at the comparable events, and maybe the building of the interstate was a comparable event. Maybe the introduction of widespread automobiles in the 1910s and 20s, Model T, maybe railroads back in the 1850s. It's tough to come up with a good historical precedent for the scope of this change that's about to hit us when we all take our hands off the steering wheels. Next slide, please, Ron.
Sure, Joe, just a point too, while you're referring to the interstate system, you know, it has been referred to as the Eisenhower interstate system of defense and, you know, various other roads. But someone has pointed out that it's took about a half century just to be able to get that information out. Eisenhower apparently took a trip from East Coast to West Coast, and it took him several months just to make that trip. And when he became president, he was very interested in getting it going. So whereas it took maybe a half century to proceed from the initial thinking of a total interstate system, still the technology that we have today, the environment that we are facing talks about very rapid movement. It won't take as long as what the other systems have shown.
Right. Yeah. Very, very good. It won't take as long. It's going to be a big change. And I guess the challenge then is, are we ready for that? Back in 1956, those guys were not ready for that change. They did not do a good job, in my opinion, of predicting the changes that would happen to American society once we built the interstates. And our challenge now here in the 2020s is to do a better job than they did, predict what's coming and get ready for it better than they did. Automated vehicles are going to change everything about our business, about our transportation system, the cost of travel. Good predictions out there is that the cost of travel falls by about half from roughly, 55 cents or so a mile now to 30 cents a mile, something like that, taking the driver out of the equation. The capacity on the roadway changes, depending on what type of road you're on. Could increase, could actually decrease some too, but it's certainly going to change. The demands on the roadways are going to certainly change, and that's tied in with both the cost and the capacity. Mode split is going to change drastically, maybe not in North Carolina so much because transit is not it does not have a high mode split here, but in a lot of other places across the U.S., transit is going to be hard pressed to maintain. And then on the revenue side as well, with NCDOT and most other transportation agencies making a lot of their revenue out of gas tax. And as we already said, the transition to electric is well underway. But even beyond that is even if we get an electric vehicle fee of some sort in place, how is that split up and what is the reliability of that? So automated vehicles are just going to change so much about our business. Next slide, please. And then digging in a little deeper, we can look at some of the technical areas. And here's just a few that I came up with, and I'm sure you could, with a few minutes thought, add to this list very easily. But on the highway side, it's going to change a lot of our business. And I'll go into details on that shortly. Other modes, already kind of talking about the public transportation mode, railroads, ports, airports, if there's a mode split, to auto away from air travel, which has already happened with COVID, but could happen again with automated vehicles, cheap and easy highway transportation. And then what does this do to non-motorized modes as well? Are people less inclined to walk or bicycle or even take scooters and such because there's reliable, easy, and cheap automated vehicles around? On the construction side, what does it do to how you construct the road and how you control traffic through that work zone? And then other areas of civil engineering coming to my mind immediately is on the water side of civil engineering. If there's less pavement, that means there'll be less runoff. And then also on the air quality and the climate side, certainly if there's, if we're changing from gas to electric, that's one thing, but if then there's more electric vehicle and how is that electricity generated? So the air quality side going to be changing quite drastically as well, I think. Next slide, please. let's dig into some of that detail to look at some of the challenges, or as Ron said, maybe turn that into opportunities here. But however you want to spin it. At NCDOT, our current design year is 2045, and very soon we're going to move that to 2050. But I think, unfortunately, our current forecast for automated vehicles is exactly 0.0. In our forecasting process, our planning, forecasting, and designing process, we are assuming 0 AVs, and yet our forecast, our design year is 2045 or 2050. This is incredible and ridiculous to me. We've got to up our game and at least try to make some forecasts of what that future might look like and try to put some numbers up on the wall. I'm an advocate of running scenarios out for that future design year. I don't have a crystal ball. I don't know what the future is going to look like. You don't either, but we can make some guesses at this point. Maybe we could bracket what the truth will eventually be, and then run some scenarios, some planning models, some traffic models, and see how things go. Run a realistic range of those scenarios and see what how our answer changes as far as our designs go for new facilities for 2045 or 2050. And then we got to be careful as we do this to avoid bias as well. There's certain communities around North Carolina that would just assume that we never build another road in their town or never widen another road in their town. And if we assume a conversion of 100% AVs and that the AVs have greater capacity than human-driven vehicles, we could show in a planning model that we will indeed never have to widen another road in their town. That's the kind of bias I'm talking about that we have to be careful to avoid. That we have to set a realistic set of scenarios and then have those be evenly applied all across the state so that we don't just get the answer that we want. We get the answer that is probably going to happen. Next slide, please, Ron. More challenges for the highway planners out there, again, looking into the long term. And I'm not a planner, but I work with some. I think I know a little bit about their business. And a big part of their business starts with a revenue forecast. They sort of have to know how much money we're going to have in the future years, 2030, 2035, 2040, to know what we need to build in 2045. And when the revenue is uncertain, it's really hard to know how to make that plan work. There's going to be a time of day travel shift. We've already seen that with COVID, right? And with COVID, the AM peak hour has pretty much disappeared. And the trips that used to be made at 8 a.m. are now being made at 11 a.m. And AVs will have a similar kind of shift, I think. And that includes a shift to 24-hour travel. When the human is no longer driving, then the vehicle can drive all night. Whether there's humans in the vehicle sleeping, or that vehicle's being pre-positioned for tomorrow morning, or whether it's a truck that is rolling across country on the interstates. There's no reason for that truck to have to stop for the night anymore. So all kinds of time of day shifts that we need to get a handle on that I don't think we quite have yet. Trip generation rates are certainly going to change how many trips each of us make. I think especially for some groups of travelers who are currently unserved or underserved, that's younger people, under 16, preteens, older drivers who currently, people who can't or are reluctant to drive, they'll start traveling more, I think, than they do now, and disabled people who are home more often or are home entirely because they can't drive or can't find anybody to drive them, will now be freed up to travel more. So trip generation rates are going to go all kinds of different ways. It's going to be really interesting to see how that changes, but it's a challenge. Yet I don't think we have a good handle on that. I mentioned trucks, the other fleet vehicles, empty trips, vehicles being pre-positioned for the next trip or the next day. That'll be out on the roads. Of course, right now there's no empty trips to be had out there. And then capacity changes. And when the capacity changes, that in turn has a feedback mechanism back into the demand side of things. At this point in our research done for NCDOT and others, we're pretty sure that capacity will rise with automated vehicle use, especially on freeways and on high quality arterial roadways. We think we know how much, but again, we're just on the edge of that knowledge. We need more, and we need to figure out how, what downstream effects that has on the whole transportation system. Next slide, please, Ron.
Joe, sorry to interrupt. Did you want the poll?
Oh, yes, we do. Yes, thank you. Yeah, so the question here is, if you were here working with me at NCDOT, based on what you know now, if you're planning or designing a road for 2045 in a suburban area of North Carolina, what scenarios would you run? And recognize that every scenario you want to run has a certain extra cost to it, so just don't check them all. But what do you believe would be realistic for 2045 suburban area of North Carolina? Check all of the boxes that you think should apply, all of them that you think we should run in our analyses of 2045. And Katie, we should give a minute or two for the responses to come back in.
Yes, we'll do 10 more seconds.
Okay. All right, and then Katie, do we get a look at the results? Yeah, there we go. I hope you can see that. So fantastic, almost nobody thinking that we should run the 0% case, and I appreciate that. And it looks like we have a pretty even split between in the mid-range, the 5 to 15, 20 to 40, and 50 to 70%, and then fewer responses for the full conversion, getting up above 80%. So yeah, good. I think that's where my head is as well. Let's run out scenarios that look at a low level, a medium level, and then a higher level of CAVs, and see what that does for our plans and our designs in 2045. So thank you for that. And thank you, Katie, for reminding me that we did have that poll. That was useful. Other challenges for transportation planners. Ron, I think we hit this slide, so on to the next. Yep, there we go. On the land use side, and this ties back into trip generation, but probably automated vehicles are going to change the look of downtown on the upper left, get rid of surface parking, maybe increase density of buildings and occupancies downtown. After all, that housing will now be cheaper downtown, and maybe more younger people want to live down there in that cheaper housing. In the suburbs, also housing will be cheaper because we won't need those driveways and won't need those garages. In the lower left, we're looking at a mall type area. Again, don't need the parking. What happens to the mall? We're already, of course, seeing a lot of impacts on retail due to the change to the web-based shopping and also COVID. Will that continue? What happens to the mall? What happens to the strip shopping center? And then finally, in the lower right, that's a ex-urban area. That's Carr Lake, an hour outside of Raleigh. Is that area going to explode with growth? Because now, after work, I can take a cheap automated vehicle for an hour, but I'm not driving, so it's no stress, and take me back to my house at Carr Lake to enjoy all the benefits of lake living up there. I don't know. We don't know. But we need to at least run these scenarios out, make some guesses as to what the land uses are going to look like. So in turn, we've got a look at what the trip generation rates might be. Next, please. So on the planner side, I think it's going to boil down to a change in mindset. Which roads, the current mindset for at least in North Carolina, which roads do we build or widen? And in the future with automated vehicles, I think the mindset changes to how do we best manage our roads? That we're sort of out of most of the building or widening business, but we're into the management business. The electronic and communication infrastructure that Ron mentioned earlier, how much information do we deliver to the vehicles and their occupants? How do we price our road infrastructure for those car companies, Google and Lyft and Tesla and whoever else is running fleets out there, and manage our routes, give people permission to use this route or that route at certain times of day, and then encourage the development we desire. If we really want to protect something like Carr Lake, we got to get out there ahead of it, and that means to manage, among other things, the road network, put the roads and manage the roads to the places where we want people to go as a society, and restrict to places that we don't want people to travel or be able to develop. Next slide, please. So let's shift over to the highway designer side of things. And we're looking at how things are going to change for those folks as well. I think there'll be a lot more cycle to cycle or time of day changes in highway design. The illustration there shows you a design that's actually operational in China now, not in the US, but they open up a gate to the left side of the median on some of their roadways heading into a signal. And now you get dual left turn lanes where you only had a single lane before. Well, that doesn't work too well with American drivers. They don't like to be told what to do. But it will work with automated drivers who don't mind being told what to do. So we'll get a lot of chances to design in a lot of those kind of features in the future. Virtual lane uses and turn restrictions. DLTI on the slide, that refers to a little experiment we're running in Cary right now, dynamic left turn intersection. That's a toe in that water of lane use restriction. When you can use a lane, we turn it on, we turn it off, depending on the demand. So that's going to happen a lot more with automated vehicles out into the future. Designers need to be aware of that and then how to use that. Pre-sort strategy, that idea is that as we approach an intersection, the left turning drivers get to be at the front of the line, the through vehicles get to be in the middle of the line, the right turning vehicles get to be at the back of the line. And then also things like buses or certainly emergency vehicles also get in the front of the queue. We can't do that now with humans, but we certainly can with automated vehicles. It can be interesting to see how we can design that. And then encouraging platooning as one drives down the road. That's a big feature of automated vehicles. They really benefit from that. Then we can reduce headways and get a lot of efficiency going with that platoon down the street. Our current kind of crude manual version of that around North Carolina are reduced conflict intersections, so-called super streets, that encourage platooning and encourage progression as one drives down the street. Again, that's just a toe in the water of the future, where a lot of our road designs will be set up to encourage that kind of platooning to get the best benefit out of the automated vehicle platoons. Next slide, please, Ron. We're going to have to redesign the road to a certain extent. Automated vehicle lanes, certainly a possibility. Narrow, probably. Separated from human-driven vehicle lanes. Again, it's about road management more than laying new pavement. We're going to figure out how to manage the curb space. That's going to be really tough, especially in cities. Do we need more curb space? Or a lot of the fronts of our buildings going to look more like the fronts of airports, where the curb space is a precious commodity that needs to be managed very carefully and enforced as well. And then how do we deal with driveways in the future? We probably don't need as many driveways. Can we reconfigure them? Can we space them out better? Can we turn them in and out, one-way driveways, whole can of worms there as far as the road design goes, how to deal with the driveways of the future. Next slide, please. More challenges for highway designers. Was certainly going to be a lot of the companies and individual consumers clamoring to be able to drive higher speeds. Now, the good news is with automated vehicles, nobody exceeds the speed limit. The bad news is, from one perspective, is that people will be asking for higher speed limits. Can we set a speed limit about 100 miles per hour on, let's say, I-40 between Raleigh and Wilmington to get people to the beach quicker? It's a straight, flat road, and when nobody's drunk or nobody's tired, nobody's making mistakes on that road, going to be interesting to see whether we can increase some of those speeds. Trucks will run at night. I mentioned that before. Well, what do you do about the extra noise that those trucks then deliver to the people living along that road at night? So that's going to change the conversation about buffers and noise walls. Road markings we know will be important for automated vehicles. We need bigger, brighter markings for sure, and we know for sure that they're going to need to be standardized. So we need people to step up there to that challenge. And then as far as signing goes as well, can we remove some signs because all that information will be delivered inside the vehicle, or make other signs at least smaller out there, save money, reduce obstacles that can be hit and such. That will be interesting too. Next slide. On the safety side for highway designers, how do we manage that mix of automated and human-driven vehicles and the mix of automated vehicles with the non-motorized modes, pedestrians and bicycles? That's tough. The research so far shows that it's a big challenge that we have not got over yet, that we need to step up with technology, with information, through a variety of means. Safety countermeasures, we don't need them anymore with automated vehicles, right? We can remove some guardrail. We can not worry so much about the side slope. It's going to change our roadway design standards, perhaps. On the other hand, and the whole set of countermeasures that is aimed at providing drivers with better information kind of goes out the window as well. So it's going to change how we think as far as designing for safety. And yeah, again, we're certainly going to need new standards. The next editions of the Green Book and the Roadside Design Manual and such are going to have to change to take all of this into account. Next slide, please. Let's talk about challenges for highway operators. Here I'm thinking about events and attractions. The picture shows the arena and the stadium in Raleigh, and acres and acres and huge space of parking that we won't need anymore. So you can redesign that whole space. What does that start to look like? On the other hand, can you imagine what happens after the game is over and 19,000 people all of a sudden head out the door and start looking for their automated vehicle, Google or Uber or Tesla or whoever. So the drop off and pickup area, it's going to change the design of those kind of places. The other picture on this slide is Yosemite. So the good news is we get to get rid of all the parking in a space like that, all the parks, all the national parks, all the attractions. The bad news is we're going to need curb space for all those automated vehicles that will be dropping off those vacationers. So how to handle that capacity, how to design for two-way traffic in and out of those attractions, and then, oh, by the way, how to collect the revenues as well. Going to be fun times for those designers and operators. Next slide, please. And then one more as far as evacuations go. When many people rely on shared vehicles, we're going to have a big challenge as far as how to manage those evacuations. We as the public agency are going to have to work with the automobile company, the Googles, the Teslas, the Fords out there to make sure they send enough vehicles down to the coast to evacuate everybody, that the route has enough capacity and can handle all the vehicles, and that the schedule, the people show up where they need to, with their 2 suitcases and their dog and their cat and whatever else in an orderly way to get them evacuated when we need to. Going to be a challenge. Next. And here I think I turn it back over to Ron to start talking about some more of the challenges and indirect impacts. Thank you.
Sure, and what we've been looking at is more the traditional direct impacts of it and the impact upon the transportation community, especially the highway planners and designers. What we're going to be looking at in the next few slides is just to kind of bring up the fact that the whole transportation system is significant. I pointed out down here that it's one of 5 basic categories of the Goose development project that we've got here as part of the major part of the economy of the United States. And because of the changes that are taking place and taking place so rapidly, the first point I wanted to bring up to you is that the timing and the action for us to be involved now, us as well as you all who are listening, because it's critical for these rapidly emerging automated vehicle activities that are taking place. I do want to point out a couple of illustrations. You know, we're in the middle of a pandemic still, and a lot of people are saying we had no idea it was coming, or if we did have an idea, we were not prepared for it. But there are some activities that we can take place. For example, I cite here back in 6 years ago, there was a report that came out of the NCHRP, and it was a pandemic-related issue. How can transit handle, and what type of guidance could be given to a pandemic? Of course, back 6 years ago, nobody really anticipated something like that would be happening, at least in the near future. But of course, it's happening now. And it was good that we had that report out because it helped to provide some initial quick action that transit agencies can be addressing. Also, I do want to point out that back in 2013, 7 years earlier, there was a discussion about connected and automated vehicles, a statement that was made saying, you know, we really ought to get involved in some of these activities, and there's a lot of things that could be done to prepare for it. So taking action now is going to be very important for us. Automated vehicles, I do want to point out that it's just an element of the total transportation system, especially as we look at ITS maturity. For those that have been involved in the intelligent transportation system, you might recall that way back almost 3 decades ago, it started off with not ITS, but rather IVHS, Intelligent Vehicle Highway Systems, with the focus on mostly the highway community and highway design. But of course, as the ITS matured, it became involved in a lot of other activities. We need to be prepared for all the other implications that will be part of the whole automated vehicle movement. Transportation delivers people, freight, livestock, crops, etc. It's a whole system of systems. So we really, when we look at what's going to be happening with automated vehicles and the impact it has, we have to look at it from a systems perspective. And of course, that tends to be the heart of what engineering is all about. So our addressing these aspects to you all today and the engineering community is going to be significant. And we do look forward to what thoughts that you might have in terms of how engineers can be having a significant impact in this whole movement of automated vehicles. I do point out that it's a systematic approach that we need to have, and it involves the both direct and indirect elements of this. And it's more than just addressing the vehicle design itself, but all the other implications. Some of the representative elements impacted, I do point out here, facilities, processes, and personnel to accommodate. And we're talking about not only people, passengers, but also freight movement. Joe has spoken a little bit about freight and the activities that we might have, the additional movement of perhaps vehicles, freight vehicles moving at night. And we do need to develop standards and guidelines for practice, for definitions. Even as we talk about shared mobility issues, that's been very popular in the past couple of years. Of course, this was impacted by the current pandemic, but it's going to be interesting to see how that comes out as the pandemic tends to go away. We go back to what might be normal or sort of an abnormal approach to mobility here in the United States. But standards will be needed. And of course, this is where the engineering community can help out a lot, not just in highway design, but in other aspects of it. Joe was making reference to noise-related issues, and that's significant too, because noise is a factor. Here in North Carolina, of course, the Department of Transportation does have a policy on noise-related issues, especially when we're talking about new construction of highways. But I do want to point out this, and we've been talking a little bit about some of the issues that are facing, not just in highway design, highway planning, but in other aspects of it. And we want to have this survey that comes out to you all. We can find out what some of your thoughts are. The question is, what impact would connected automated vehicles have in your particular area of professional interest? And how would you prepare for that impact? This is a question to you, and Katie, is this, can we go ahead and send this out to the folks?
Yes, so what you're gonna do is go ahead and type your answer into the chat box, and I will read those comments out loud.
And I hope we didn't catch people by surprise.
I don't see anything coming through the chat box yet.
Okay, well, we'll go ahead and leave that in there if possible, but just as a stimulus, as a thinking piece, where that might be impacting your own particular area of interest or professional expertise. We will go ahead and move on, though. I do, last bullet down here, it's just kind of a warning as we look at this whole systems aspect with respect to how and where the automated vehicles may have an impact. I do want to use an example coming from the ITS community. As we begin to look at ITS and the ability to move and have information data flow within the urban area, there was a need to go ahead and look into the rural area as well. And initially there was some thinking that it was recognized that the federal government does have involvement, sometimes local, state, but it was really considered to be kind of minor as we moved into the connecting activities, because we wanted to be sure that we brought in all of the impacts from different areas. But to the surprise of many people, instead of finding just a few little links that we needed to tie into, what we found here was a whole variety of different networks that already were in existence. There was not only the federal government role in transportation in both urban and rural areas, there was also state, there was local, regional activities. There were not only transportation related things, there were health and human services related activities, but all these, because of the connecting activities and the framework that was necessary, and looking at a systems approach, we need to bring in everything. This is not necessarily the study, but at least just to give an idea that you might find a lot more involved when you begin to look at what the impacts are for automated vehicles. Some representative components of this, of our demand for transportation, personal consumption, of course, motor vehicles, and parts and supplies and everything else. It's interesting that that's especially important because even just the other day when I went ahead and put in my registration for a new vehicle license, I found out that I had to provide the various property taxes that's necessary for the state, the local area, the city as well. So transportation has an involvement in a lot of these things. Government investment, of course, is significant and has a primary role in what we're doing. Private domestic investment is also a key factor here. Retailers, imports and exports as well. But all these have a significant impact and sort of an indirect impact as we're considering what will happen with automated vehicles as we move forward. There are a number of activities that are taking place in different societies and different groups. This is just a listing of a few of them. And hopefully you all in some of your professional activities and involvement have other things going on. It is interesting, but the U.S. Department of Transportation, not only the DOT itself, but also the White House has been very involved in this with respect to some of the things that are happening. The interesting thing here is that there's a lot of formal activities that are taking place with respect to the United States government. The White House has recently gotten involved in developing and promoting the whole idea of automated vehicles, primarily from a safety aspect. But one of the things that's interesting is to see how quickly the federal government has been moving. Back in 2016, there was an initial federal automated vehicle policy that was brought out. The focus was on safety, and what it referred to was a federal government ambitious approach to accelerate the automated vehicle revolution. And it's not often you'd find a US government publication talking about a revolution, but still a reference was made to an automated vehicle revolution taking place. A year later in 2017, there was an update, Automated Vision number 2, as it was called, in 2017, which identified the safety-related issues, addressing the fact that automated vehicles can lead towards fewer fatalities and increased mobility. Once again, a year later, there was another document came out, Automated Vehicles 3, Preparing for the Future of Transportation, Automated Vehicles. What the emphasis there was upon safe, reliable, and cost-effective integration of automation vehicles. And finally, just this year in January, there was a 4th version that came out, Ensuring American Leadership in Automated Vehicle Technologies. So more than safety, what the US government, and this was tied in with both the US Department of Transportation as well as the White House, which is primarily the stronger interest areas. And the White House was very influential in getting involved, not just in transportation related issues, but they also provided a strong emphasis to the Department of Agriculture, Department of Defense, Energy, Health and Human Services, Homeland Security, Justice. NASA is involved, National Science Foundation, and the United States Postal Service have all been strongly influenced and directed to go ahead and be preparing for automated vehicles. So this is just something that the United States government is doing, but also these other activities and societies have already been actively involved. ITE with its Connected Automated Vehicles Initiative, ITS America, which is an advocacy group for material conferences and sessions, American Society of Civil Engineers advocacy, as well as current online discussions, committees, and conferences. Transportation Research Board, of course, has several committees that are addressing the automated vehicle aspect and implications of it. And SAE, the Standard Development Group of People, have been very active in different activities, including the shared mobility related issues, where they developed a taxonomy and already have made a standard for this, and others. And this is where we'd like to hear from you all. There's still time for you to send a comment back, or maybe part of the chat box that was being referred to, areas where you might be involved and be able to be involved. Well, that's some of the things that we'd like to present to you all. But I do want to point out, though, some of the different aspects of different disciplines. We've heard about different activities here. Some of the examples that we're talking about in terms of your own area of engineering expertise, aerospace, agriculture, bioengineering, environmental related issues, especially when it comes to noise, industrial materials engineering, metallurgical, mechanical, nuclear. So all of these have an impact upon this new development of automated vehicles. So the question to you all is, which disciplines are not impacted by it? And I don't think we'll find very many, but which disciplines are you more aligned with, and where could you be actually participating in sharing some of your expertise and helping with activities? Once again, we do want to point out that we are optimistic. There is a hopeful future with AVs. What we're looking at here is the safety aspects of it, less expensive, quicker in terms of being able to develop mobility, the availability for more people, the whole idea of less stress in terms of the mobility aspects of our lives themselves, and of course a better environment of it, better for commercial areas, businesses, as well as creating more jobs through the use of automated vehicles. Actions that we are anticipating needed comes from a variety of sources, from the federal level in terms of legislation for vehicles themselves, standards being developed statewide, also legislation, court-related issues have an impact, local governments as well. So we're looking at all different levels of government area, but more than government, we're looking at the private sector too. And this is where I want to be sure we brought out some of the professional societies that are actively involved, citizen groups, organizations, public and media. Don't panic, but rather look for optimistic activities that we can be doing together. And we're looking for the need for training people for various new businesses. The workforce is going to be very important as we move into this whole area. And of course, research as well is going to be necessary. Research, development, and implementation. The challenges for us in the engineering community. One of the areas listed above, the professional, it's going to be changing. What we try to do here in our presentations, bring out the fact that it's more than just in the transportation, highway design activities, but it's going to have impact throughout. New relationships, we've got new inputs, we've got standards being developed, and this is going to result in new processes, plans, and designs that we've got here. Our recommendations, we want to be sure to point out that let's go ahead and move on. Let's be doing something. Continue your education. Think through our own areas of involvement. Problem statements could be developed. We can be joining committees. We can write, present, and educate others. And as Joe had mentioned earlier, put up a number. Let's put it on the wall and let others, shoot at it. Let's go ahead and engage in dialogue and keep on going with this. We do want to finish up with this, with our invitation for any follow-up that you all might have. We've got our telephone numbers as well as our email addresses as well. Joe, any other final comments?
Ron, I just wanted to add that quote on the last slide there was, I think that was from my boss at my first job in engineering 37 years ago. And it still rings in my head, and it's still more true than ever. We never get anywhere if we don't pin that number up on the wall. So let's start looking ahead at whatever branch of engineering you're involved in. What's going to be the effect of automated vehicles? Take a shot at it, post some scenarios, put some numbers up on the wall, and start that dialogue. And that's how things should progress. And that's our challenge for the next couple of decades here to continue to refine those numbers. So appreciate the chance to talk with you today about that.
All right, we do have a couple of questions that have come through. When the software or hardware on an automated vehicle becomes obsolete, like an old computer, will these vehicles become useless and require replacement?
Ron, let me tackle that to start anyway, and to say that no, the software that I understand anyway, software will be updated regularly on the automated vehicles, and then hardware that will be a tougher one. And yes, due to hardware becoming obsolete, vehicles might have to be retired quicker. Of course, vehicles in subscription service, just like a rental car fleet, will cycle through much more quickly than vehicles that are privately owned anyway. So the obsolescence will be less of a problem later than it is now with mostly privately owned vehicles. Ron, do you have something to add there?
Right, and we're still getting updates on some of the technology and software that I've got. Just yesterday, I went ahead and responded to we built a car a couple of years ago. And once again, they were updating the software for the navigation system that we have here. So that's already being accomplished in terms of periodic updates that are necessary for the software.
All right, another question. DOT has been experiencing extreme cuts in their budget with roads not being maintained like they were just a short period of time ago, and even medians are not being kept mowed in the past several months. To make this work, how will the added costs to make this work be addressed? Is this being discussed among the leadership at DOT and others?
Again, I'm going to jump in mostly because I'm at DOT currently. I became a convert to automated vehicles 3 or 4 years ago when I realized that DOT's investment is not going to be that large. We need to do the right things and change our way of business in a lot of ways, but it's not like we have to build a whole new infrastructure to accommodate the automated vehicles. My focus in this presentation, many others, and in my book, is much more about the automated than the connected part of the business. The connected, especially where we connect the infrastructure, that's where some big investment could be. But my understanding, and I still believe that now, is that most of the vehicles running around out there will be quite autonomous and will be able to complete their trip, whether they get information from us as the DOT or not. Ron, if you have something else.
Right, no, nothing else to add on that particular comment.
All right, we'll do one last quick question before we wrap up. The presenter's assumption seems to be that AVs will always be a rental situation. Doesn't that assumption ignore the totally annoying problem of not having a vehicle available during rush hours? Will lots of people want their own AV so they can go when they want to?
Ron, you want that one?
Sure, let me go ahead and clear that.
Yeah.
Yes, we did talk a lot about the shared vehicles, the shared mobility related activities, but there will be, as the commenter points out, there will be the opportunity for individuals to once again own their own. Our focus that we had on this presentation addressed more the general aspects of it, but we're looking at it the long term. But the commenter is right that we would expect that there would be that there would still be the ability for people, and not only the ability, but people actually using their own vehicles, automated vehicles for their own personal use, and not renting it out or sharing it with others.
But I want to add, the subscription will be so much cheaper. When you run out the numbers, it's really pretty awesome how in a suburban area like the Triangle or Charlotte, that subscription is going to be half the cost of owning your own, or maybe less than half the cost, because owning your own automated will be expensive. So that's going to come into play, and I think many of us as consumers will get accustomed to waiting a couple of minutes for a vehicle to arrive to take us home in exchange for saving so much money on the subscription versus owning my own. So I agree with Ron, owning will always be an option, but it's going to be awfully tempting to want to subscribe.
All right, Joe and Ron, thank you so much for your presentation today. We really appreciate it. Attendees, thank you all for participating. If you have additional questions, I know we did not get to them all. You can see their contact information on the screen there. Your PDH form and your NC Bell survey will be emailed out this afternoon. Please join us on Wednesday, July 22nd for the PENC officer installation and membership meeting. Details are available on our website. Thank you so much, everyone, and we will see you next time.